Now let's look at the first example from LeetCode. This is called assign cookies. So it's a fairly simple example to illustrate the concept of greedy algorithm. So we have a number of children. Each child has a greed factor, which is the minimum size of cookie that the child will be content with. And then we also have a bunch of cookies, and they all have a size. So we want to maximize the number of content children. So if we assign a cookie that's big enough, at least as big as the child greed factor, then the child is content. So we want to maximize the number of content children. And the goal is to compute that maximum number. So let's take a look at this example. So if we have 6 children, actually 5 children. The greed factors are 2, 3, 3, 5, 8, and we have 5 cookies: 1, 3, 3, 7, 10. So I think it's pretty obvious. Look at this. We can satisfy 4 of the children. So now the question is how to solve this more generally. So there are different ways the more than one ways to solve this problem, but one insight is if we can satisfy K kids, then we can satisfy the K kids who are content with cookies of smallest sizes. So for example, here we could satisfy this 8, 5, 3, 3 by using 10, 7, 3, 3, so corresponding order. But we can satisfy 2, 3, 3, 5. So if there is a solution to satisfy 3, 3, 5, 8, we just replace the 8 with the 2, and whatever cookie that we gave to 8, we gave to the 2. So then that definitely will make the kid happy because he will be demanding a smaller cookie. So this means that we can consider the children from the order of the least demanding to the highest demanding. So this argument here is formally known as the exchange argument. We are saying we only consider the kids from the order of what they demand is smallest, and this will guarantee to find the optimal way, because if you satisfy any other group of K kids, then by exchanging each of the kids who demand more with the K demand less, then we will get a solution to satisfy the K kids who demand the smallest cookies. And then there's so we need to sort the kids based on this order. So that's kind of one hallmark of greedy is we sort it and then process by some order. And then we start from the kid who needs the smallest cookie. Then we also process the cookies in a sorted order. So for example, we look at the first cookie. We're trying to satisfy the kids from the smallest first, because so because of the exchange argument. So 1 doesn't work, doesn't satisfy anyone. So we look at 3, and 3 can satisfy 2. So 2 is satisfied. We have a solution to satisfy 1 kid. We look at the next one, 3, and then we look at the next cookie and satisfy that. And then 7 satisfies 3, 10 satisfies 5. So we satisfy 4, and we are out of cookies. So that is one way to solve this problem. Another way of solving the problem is we think in terms of the cookies instead of the kid. So then that means we should use the cookies that are biggest. So if we if we use K cookies to make K children happy, then we will be using the K biggest cookies. So then what we can do is we start from the biggest cookie and then see what is the most demanding kid that cookie can satisfy, because it's always better to satisfy that kid instead of satisfy some other kid, because now after we satisfy, for example, giving this 10 to 8, we have a set of less demanding kids. So anyway we can satisfy K there. Anyway we can satisfy K with this 8, we can also satisfy without this 8. So So we can also looking at each cookie, but then we'll be looking at from the biggest to smallest. So both approaches will work. And this is my code for the first approach, which I think result in slightly shorter code, maybe 1 or 2 lines shorter, because we don't need to explicitly keep track of the number of kids that satisfy, because we just look at each kid in turn. So we sort both arrays, and then we have 2 index, one point to the greedy, the other point to the cookie size. So we are basically trying to satisfy the kid corresponding with this ID. So we will keep going until we satisfy all of them. And while here, we will keep going until we either run out of cookies or have a cookie that's big enough. And here we check if we actually run out of cookies, then we're done. Otherwise, we will use the current cookie to satisfy the current kid. And at the end of the loop, we simply need to return what is the current ID to the kid we are considering, because that's the same as the number of kids who have been satisfied.